Hi friends, Joseph Kursky here with you to guide you through the process of accessing, downloading, and using data from the national map. We're going to focus on ArcGIS Pro, but it could be applied to any GIS. Go to the nationalmap.gov, go to the bottom of the page, and get elevation data. It's strange that it's at the bottom of the page, but there it is. Then I'm going to select a study area. I'm going to select Grand Junction, Colorado, in western Colorado, beautiful part of the world. Note on the left side, you've got some file format choices and some product search filter choices. I'm going to select Lidar Point Cloud Arc Grid 1 meter DEM as my choices. Then I'm going to draw a box after selecting the box or point choice at the top and further refine my study area. Note my availability legend on the left side. Okay, now I can save my choices as a CSV file, which is actually quite handy. I can come back to that later with some metadata for my choices, but I could also at this point return to search and look at the different products that are available for my study area. I can see some metadata here for the footprint, and as I scroll along, note that the footprints are displayed on my map, the outlines of the footprints. And I'm really interested in this one right here that encompasses this ridge, as we'll see in a bit. It'll allow us to do some really fascinating northeast versus southwest slope comparisons. So now that I've got that particular one, I'm going to go ahead and look at the metadata for it. Here's the metadata for this particular data set. Note that it's a LAS file. We're going to zoom to it. We're going to download it. It's downloading to my local device. It's a zip file, so we'll need to unzip it. We'll go to the Downloads folder and we'll take a look at that zip file. In my case, it's about 187 megabytes. I'm going to move it to the place where I actually want it to be stored and used. It's going to be part of my ArcGIS Pro project. And then I'm going to use 7-zip. In my case, you can use any zipping or unzipping program that you'd like. That will work. 7-zip works rather well. I'm going to unzip it to this folder. And now I'm going to get a LAS file, an HTML, an XML, a TXT, and a NED data dictionary, and a couple of other things. And I can look at that text file and get more metadata there. Okay, so we've got it downloaded from the national map. We've got it unzipped. We're ready to go for ArcGIS Pro. Let's take one last look at the HTML version of the metadata. And so we've got three versions, one on the web, a text version, and an HTML. Now I'm going to create an ArcGIS Pro project here. So I'm going to fire up ArcGIS Pro. This will work for 2.0 or later. I'm going to start a blank project here, or a new project. Note the path names. Find out where you want it to go. I'm not going to create a new folder. I've already got a folder there, so I'm good to go creating a folder to store my project. I'm going to put it in my Lidar data folder. That all looks good, so I'm going to select OK, and I'm going to give it a suitable name now. Book Cliffs is the local terrain that I'm studying, so that part is great. Now I've got my Pro project set up, and I'm going to load my Lidar data into ArcGIS Pro right now. So let's take a look at the files we've got just as a review. I've got a toolbox, an APRX, which is my ArcGIS Pro project, and a couple of other things. I've got a geodatabase as well that it's set up for me. So I'm going to load my data into that geodatabase, my LAS file. There's my geodatabase that was set up when I created the ArcGIS Pro project. I'm going to go to Analysis, Tools, and I'm going to search on Create LAS Dataset. Now sometimes you're able to bring in LAS files directly into ArcGIS Pro into a map. Sometimes not. It depends on how the LAS files are set up. In this case, I actually need to create a last data set before I bring it into the map. So I'm going to navigate to my last file. I'm going to go ahead and open that, and I'm going to output it into a last D, which is a last data set. Note the coordinate system and projection of your LiDAR data. It is, in my case, in UTM Zone 12 North. But you want to pay careful attention always to the projection information. And so if it's not projected, you'll need to define projection. In my case, it is projected, and that's great. So I'm going to go ahead and run that. It's creating a last data set and successful creation of that. Perfect. So I've got my last data set inside ArcGIS Pro from the National Map LiDAR data set. UTM coordinate system. Super. All's well so far. We are doing great. You can check the geoprocessing environment if you'd like. That way you can semi-automate the connection and folder information. I'm going to go ahead and insert a new map now, as you see here, so I can actually see my data. I can go ahead in the catalog pane on the right side and expand that, and I see my last data set right there, as well as a couple of other things, including the metadata. There's my file extensions. But my last data set is one I want to drag over to the map. So I've got a topographic map base, which is showing up right now. If I zoom in just a little bit, I see my point cloud for my LiDAR data. Ah, looks nice. Now I can do things with it, right? I can create a slope map, an aspect map, all kinds of things. This is my ground photograph of the area of interest. This is my study area showing the ridge that you are examining right here that's running from the northwest to the southeast part of the map. Okay, now let's go ahead and visualize the LiDAR data that you've brought in from the national map. If you go to this Appearance tab, Symbology, you've got some choices there. Let's go ahead and select Elevation. And we'll just take the default for starters, 9 class, natural breaks, Jenks, University of Kansas, rock chalk. So that's what that area looks like. Okay, ranging from blue, low elevation, to reddish, high elevation. And now I'm going to go ahead and create a slope, visualize it as a slope map. And so I can click around here and get the elevation and the slope and the aspect, the direction that the slope faces, in degrees. All right, so far so good. Easy to bring in this data into Pro for sure. Now let's go ahead and create an aspect map, the bluish meaning that it's facing southwest, and the reddish facing toward the northeast with that sharp ridge in there, as you see. And that's with a default 10 class aspect map inside ArcGIS Pro. Let's go ahead and create some contours. Visualize this in contours now. Now I can click around and see the elevation, slope, and aspect once again. And I'm taking the default at the moment, drawing the contours with a contour interval of 5. It's important to note the elevation units, of course, this being in meters. So know your data, examine your metadata to see what your units are. So we've made a slope. We visualized it as slope, aspect, and contours. Now let's create rasters from the LiDAR data. We've just visualized it so far. We haven't really created any data set indicating slope or aspect or anything else. So let's go ahead and do that. So last data set to raster is our tool that I searched on, as you saw. And my input is the last data set. My output is going to be bookcliffs_raster. And my value field I'm going to make as elevation, taking a look at some of the choices there. I'm good with all of those things. I'm going to go ahead and select Run at the bottom. So now I'm running that last data set to raster command. It's a tool. It's a geoprocessing tool inside ArcGIS Pro. Once done, now I've got a raster data set for my last file. I can go ahead and go to Last Filters now and select Ground. I can also go to Last Filters and select First Return. What does this mean? This means I'm going to get what the ground surface is, and also the first return. In my case, the first return is really going to be from the vegetation. So I'm going to get a vegetation surface, if you will. And now what I'm going to do is convert last data set to raster, and I'm going to make the output Book Cliffs ground. So now that I've filtered it to ground, I'm going to convert last data set to raster and run that, taking the defaults here. Now I've got a ground surface. Should be bare earth. Now if I select first return, and now with the geoprocessing tool last data set to raster, I'm going to call that output first return. Now I'm going to have a raster of the first return. In my case, it's the tops of the vegetation, pinyons and junipers in this case, especially on the northeast facing slopes. In your case, it might be buildings, it could be something else that's giving you the first return. But now my objective here is to compare the first return from the ground. So I can look at the values in there, in each one, the first return and the ground. Super. Now let's use the raster calculator to get the difference between the first return and the ground. So here's the first return and the ground showing up in my choices. I'm going to take the first return minus the ground, both of them being rasters. My output raster is going to be named Book Cliffs because that's the area of interest for me. That's my study area, the Book Cliffs. And I'm going to call that vegetation height because that's really what it is in my case. The first return is the tops of vegetation and the ground is the ground surface without the vegetation. So subtracting the two is going to give me basically the vegetation height. Should be basically 0 on the southwest facing Manco Shale slopes. They have no vegetation, as you saw in that photograph that I took on the ground. And now I'm going to change the colors so that I can visualize this perhaps a bit better. Now I'm going to change the symbology to classified, natural breaks. Is that giving me anything better? In some ways it does, because now I can see that I do have a higher vegetation height for the northeast facing slopes, which was my objective to show. The northeast facing slopes and the northeast part of this image is the pinyons and junipers. The southwest facing slopes are truly just the Manco Shale, so there's no vegetation whatsoever on those slopes. And that gives me exactly what I was hoping to see. That's good. I'm going to go ahead and change the base map to a satellite image so I can see the satellite image of that area. Now you can see the pinyons and junipers on the northeast side of the study area and the bare earth Manco Shale on the southwest side of the image. Excellent. And of course I could make this semi-transparent and look at the data with the satellite image below it as well. Take a look at some of the metadata here. All right, now let's make a hillshade out of our ground raster. We're going to take the defaults for the azimuth, which is from the northwest, the altitude 45 degrees above the horizon, and we'll call that hill SH for hillshade. We're going to run at the bottom there, and there's our hillshade. Zoom out a bit. Now we've got a very nice looking hillshade there, visualizing the surface. Now let's go ahead and create contours from Lidar data. Geoprocessing tool contour. The input raster is our ground raster, and our output polyline features is our Book Cliffs contour layer that we're going to create inside our geodatabase. Everything is being saved inside our geodatabase for this ArcGIS Pro project. I'm going to give it a contour interval of 5. It's in meters. So again, know your metadata, know your units. In this case, meters. And I'm going to let it create those contours, and there we've got it. Excellent. Turn off one of those layers in the background. There we go. Turn off that hill shade. Now I can see the contours on top of my satellite image. So I can see the steeper slopes off to the southwest and the gentler slopes off to the northeast, where the pinions and junipers are. So there's my contours. Very nice. I'm going to label those. I could spend a little more time making these labels look nicer than they are, but those are the default labels. Change the symbology if I wish. And I could change any one of these labels if I wanted to. Let's go ahead now and create and symbolize index contours. I'm not happy completely with my contour line, so if you'd like to create index contours like you see on most topographic maps, here's how to do it. You want to use the contour with barriers command or tool. You've got some choices there on the indexed contour interval, which is going to give you that thicker line. So I'm going to turn off a couple of these other layers so you can see this a bit better. Let's take a look at the attribute table now. And notice that I've got a type 1 and a type 2 after I run that tool. So now it's a matter of symbolizing on type 1 or type 2. Type 2 meaning that it's the index contour. It's the one I want to make thicker or heavier or a different color. Your choice. So let's go to that layer and just check out the values here through the labeling function. And now we'll go to symbology, and as I was indicating, we can go ahead and go to unique value and go to type, and now type 1 and type 2 shows up. And let's make type 2 a bit thicker and heavier. Your choice, of course, on colors, dashed versus solid, thickness, etc. I'm quite happy with that. That's looking pretty good. So my regular contours are thinner, my index contours are a bit thicker and a different color as well. So I've got lots of choices in the symbology zone inside ArcGIS Pro. I've got a gallery, I've got properties, I can create my own custom symbol as well, save that, come back to it later, and so on. Wonderful. Okay, that's looking pretty good. I've got my index contours there. I've got the labeling on, so the labels are dynamic, as you can see. And the labels are kind of getting in the way there, but let's turn those off and go ahead and that's looking quite nice. I'm very happy with that. So that's creating what we call index contours with that contours with barriers tool inside the geoprocessing tool and inside ArcGIS Pro. Let's take a look at our study area once more. This is what we've got. We've got that southwest facing Manco Shale, steeper slopes, and the gentler slopes off to the northeast, which is the pinions and junipers. Thanks. Let's go ahead and create slope and aspect maps from our Lidar data inside ArcGIS Pro. So our input raster and our slope geoprocessing tool is going to be my raster created from the Lidar data, and I'm going to call my output Book Cliffs Slope. Book Cliffs being my study area, Book Cliffs, Western Colorado. My output measurement is in degrees, and I'm going to take the defaults for the rest of it. Know what the choices are on all these toolbox commands. inside ArcGIS Pro. You've got lots of choices there. And I'm going to click around on my new slope map. It's in degrees, remember, so I can see the different slopes in there. Excellent. I'm taking the default classification method, but of course I could change that if I wanted to. Let's go to the Analysis Tools and create an aspect map now. Aspect Spatial Analysis Tools. Our input raster is going to be our raster dataset created from the last Lidar file that I downloaded from usgsnationalmap.gov. And we're going to call this one our Book Cliffs Aspect Map. I'm going to take the default there. Again, know the choices that you have and what they can do. And now I've got a direction of slope or an aspect map. That's looking quite good. Now I can see the northeast facing slopes and the southwest facing slopes. So I've got a direction of slope there for my aspect map. Super! I'm quite happy with that. I've got a slope, I've got an aspect, I've got my contours created. Let's go ahead and open up a new scene and visualize this in 3D. So now let's create and use some 3D scenes inside ArcGIS Pro from our original LiDAR data downloaded from nationalmap.gov and brought into ArcGIS Pro. So I've inserted a new 3D scene into my ArcGIS Pro project. I'm going to convert my map to a 3D scene. So I can see these side by side eventually. I've got my controls there at the bottom that I can use to navigate around on my map. I can click on individual points there and see what my values are. So I've got a 2D and a 3D map inside ArcGIS Pro. There's my 2D layers, contours, aspects, slope, my hill shade, etc. But I also have the ability to bring those into 3D. Really quite exciting. So now I'm looking at my aspect map, my direction of slope map in my 3D scene. So I can see the direction of slope. There's my contours draped on top of a satellite image, which is coming from ArcGIS Online. So you've got seamless desktop and accessing of the cloud information, so that satellite image is not resident on my local device. It's actually coming in from ArcGIS Online, which is really quite amazing. And you've got access to all the living atlas layers and other things, the thousands and thousands and thousands of other layers inside ArcGIS Online. So I can zoom out now and see the edge of the Grand Valley, which is my study area here. Really amazing to be able to do this. I can take a look all the way into Utah and all the way up into northwest Colorado with my study area. Alright, so let's zoom back down to our study area itself and take a look at that in our 3D scene. Ooh, so now I can really see the data that I generated, all from the LiDAR data. This all came from LiDAR, with the exception of the satellite image, of course. That came from ArcGIS Online. Taking a look toward the northeast now. So I've got a 2D and a 3D map. My 3D is a 3D scene, but I can look at my layers inside my 3D scene inside ArcGIS Pro. Taking a look at my slope layers, my hill shade on top of the satellite image. It's looking good too. Let's change the base map to a topographic base map now. This is the World Topographic Base Map. Since this is USA, I also have the ability to change it to a USGS topographic map. It's not one of the preset base map choices, but I can go ahead and add data and use the Add Data button, and I can go to All Portal, which means ArcGIS Online, and I can search for USA Topo, which is the USGS topographic maps. I can see that choice right there at the top, and I can say OK, and I'm going to get my USGS topographic maps now as a base map. Very nice. Oh, there they are. Great. That's looking really good. There's Mount Garfield, which is off to the southeast of my actual study area, but now I can see the topographic maps at different scales, 1 to 24,000 scale if I zoom in, 1 to 100,000 scale if I'm zoomed out just a bit at a smaller scale, and then smaller scale still, if I zoom out just a bit more, I'm going to get the 1 to 250,000 USGS topographic maps, all from that seamless streaming in from ArcGIS Online. Very nice. There's the 1 to 100,000 scale if I zoom out just a little, so I can see the Grand Valley and my study area off to the northeast there along the Book Cliffs. So there's the Grand Valley, and zooming out you can see a little bit of the 1 to 250,000, and there's a 100,000 scale USGS topo maps. Excellent. Super. So we have made a 2D and a 3D scene inside ArcGIS Pro, and we can go flipping back and forth between the two so we can visualize our data and create derivative products as we've done. We've created a slope, an aspect, and contour lines and other things. Let's go ahead now and add data from ArcGIS Online in the Living Atlas of the World. Now, in the previous section, we added some base maps from ArcGIS Online. Let's go ahead and add the world hydro. Let's say we're interested in a drainage study or a hydrographic study from this study area. So let's say we want to find out where this drains to. We can see this cuesta is really what it is. It's a ridge with different slopes on either side of it. We can zoom out from this world hydro layer, which is wonderful because you get the hydro lines and you also get the watersheds. The watersheds are showing up in this dashed brown dotted line, actually is what it is. And you can see that we're at the edge in this study area of two different watersheds. The Sink Creek Colorado Plateau, and off to the northeast is a different watershed entirely. So that ridge line, or cuesta is really more appropriate name for it, is dividing the two. And that all came from ArcGIS Online, and you've got access to thousands and thousands of other layers inside ArcGIS Online, including a authoritative body of content called the Living Atlas of the World, which is available right there. Wonderful. Let's go ahead and click on USA Detailed Streams, and now we're going to get some more detail for the hydro, as the name implies. USA Detailed Streams. You want to be a little patient here because these USA Detailed Streams they're quite voluminous, as the name implies. They're detailed, so have some patience. It's all streaming in from the web, which is pretty amazing, but we can go ahead and click on individual streams now that show up and get more information about each one of them. So it's a rich data set. What we're doing now is we're linking the views between the 2D and the 3D, so we can go ahead and visualize both of those things. Very nice. On the right we've got the 3D scene, on the left we've got the 2D scene, and as you can see they're synced together. Very easy to do with ArcGIS Pro. View, link, views. So this could be handy for lots of things, right? Urban studies as well as the rural study I'm doing here, so you can look at buildings and human infrastructure and things like that. Campus trees, fault scarps, all sorts of things. Let's take a look at our data. We want to change our map properties to something besides decimal degrees. Our data is in UTM, so let's make the units UTM for the bottom of the map. And so we've got the ability to do that inside layer properties. Take a look at the other metadata in there. Okay, very good. Now let's go ahead and check the metadata and the map projection inside ArcGIS Pro. Easy to do because you're just right-clicking on your layers. And you've also got the map The map, just like a data frame in ArcGIS Desktop or ArcMap, the map in ArcGIS Pro contains the coordinate system for the first layer that you bring in. So if your first layer is state plane, your map is going to be in state plane units. So it's important to check the metadata as I'm doing here. Let's go back to our original metadata for our last file, which is what we brought over from the usgsnationalmap.gov site. So I'm going to check the metadata for the last file, and I can see the coordinate system there and the map projection. It's in UTM zone 12 north in my case, so when I go back to ArcGIS Pro, I can see and verify that it's truly in that projection. So I can go to map properties, the extent, and I can get the spatial reference in there, check the surface values and so on. Here's my coordinate systems area. I can see that it's in UTM 12N NAD 83. Again, the data is important. The datum is also important. So that's how to check that. So we've checked the metadata. It's important to do. Check out our metadata, all things geospatial data blog, spatialreserves.wordpress.com for more. Let's create a surface profile now from our original last file, which is a Lidar file brought into ArcGIS Pro. We're going to use the geoprocessing profile tool to do that. And I'm just going to draw a couple of lines across the cuesta or the ridge inside my data set. So I can just draw, or I can use a predefined shapefile or a geodatabase feature class that's a line, or a polygon for that matter. But I've just drawn a line in there. So there is a profile graph tool, and I can go ahead and click in there to get the individual values. But along that line that I've drawn, that's now in cyan color, there's my profile sort of cross section, if you will, starting off with the steep slopes and then almost a cliff right there, and then the gentle slopes off to the northeast. Notice that I've got different display units possible here, so I can change it from meters to feet for either the vertical or the horizontal, or kilometers if you've got a very small scale sort of zoomed out data set that you're looking at. Yep, so I've got lots of choices there for my chart. It's a chart, basically, is what this profile graph is. It's a chart. All right, so we can select it if we want to. Select pieces of it. Filter it, and so on. We can export it into a graphic file if we wish, which we will do here. Call it profile. And now we've got it saved to our device as a graphic. And there it is. There's our SVG in this case. Simple but effective. Excellent. Let's go ahead and examine our elevation using the Summarize Elevation Geoprocessing tool. If we open up the table for that Summarize tool, we get all kinds of interesting things that we can do stuff with. Minimum, mean, maximum elevation. And this all came from the Lidar data downloaded from the usgsnationalmap.gov. See my related videos about Lidar. So we can select individual contours, of course, and zoom to them and get more information about each one of those contours. Super. Looks great. Let's go ahead and create a viewshed from our original Lidar data that we've created raster files from inside ArcGIS Pro. So the viewshed tool allows us to visualize and assess how much terrain is visible from a certain point or points on the ground, or a certain distance above the ground. So let's say our observer height is 2 meters. and we don't want any surface offset. We're going to go ahead and visualize how much of the terrain we can see from that point. So you could use this for things like planning a fire tower or other things, or planning a new building, etc. So from that spot that we've located, these areas in this sort of orange color, brownish color, are the areas that I could actually see on the ground from that spot, from that push pin that's in the cyan color. Of course, I can change the symbology of the resulting viewshed layer if I wish. But easy to do. Output viewshed. Lots of different applications here. So it's the appearance. You can also make it transparent if you'd like, as I'm doing right here. Let's go ahead and trace downstream inside ArcGIS Pro from data that we originally brought in as Lidar data from nationalmap.gov. Let's go ahead and use the Trace Downstream geoprocessing tool. I'm going to give it a point on the map. I could also use as an input a feature class point file. From that, I can see that my trace downstream is leading off to the southwest. Where does that go eventually? It goes into the Grand Valley and then down the Colorado River, as you can see here, all the way from Colorado into Utah, panning on down through the Grand Canyon, into Arizona on the California-Arizona border, into Mexico, and over to the Gulf of California. So that's my trace downstream tool. Quite easy to do and quite effective. And now I've dropped another point off to the northeast in my study area, and I can see that that trace downstream goes off to the northeast, eventually joining the Colorado River and joining my original path. So I'm going to change the symbology for one of those traces, and now I can see both of them inside ArcGIS Pro using the Trace Downstream tool. Now I also have a 3D scene set up, so I could look at this in my 3D scene as well. Now I've linked the 2D and the 3D views, or scenes, if you will, and so now I can see the 2D view and the 3D scene side by side, looking at the trace downstream and looking at my terrain, as well as my viewshed that I've created in a previous step. Great. Let's use the raster calculator inside ArcGIS Pro. This is extremely similar to the raster calculator in the ArcMap environment or ArcGIS desktop environment. Let's say I want to compute which slopes are above 40 degrees. I'm going to give it an output raster, but I'm using the Boolean and arithmetic tools inside there in the raster calculator. You can see that it's quite intuitive. My slope is greater than 40, and give it an output raster and go ahead and run at the bottom. And what it's going to give me is, of course, those areas in my raster that are above 40 degrees in slope. So let's go ahead and visualize that now. Let's change the symbology, turn off some of the layers from my trace downstream that I was using in a previous exercise, and bring that data set in to my map just by dragging it over from my catalog pane. And now I've got zeros and ones. Zeros did not meet the criteria, so I'm going to give that no color. Ones, I'm going to change the color to something I can easily see, like yellow. And so now I've got those slopes above 40. Very nice. So I can see that steep cuesta or ridge right in there, and also some of the slopes off to the southwest. I've got just one slope off to the northeast that's above 40, but the rest of them are a bit gentler. Very nice. So I can select that inside the attribute table. I've got two things in my attribute table for my raster, which is basically not really an attribute table after all. It's really a summary table for that raster layer, as you probably know, but it gives me the number of pixels that meet both of those criteria, less than 40 and above 40. So I can visualize it here in 3D, looking at which slopes meet my criteria, and I can use this for a variety of purposes. Looking at fire mitigation, fire towers, watershed studies, soil stability, and other things. So that's the raster calculator. It's very similar to the raster calculator in the ArcMap environment. Actually, I believe it's even more intuitive. So you're basically constructing statements in that raster calculator. Let's go to the Appearance tab underneath the raster layer. Alright, super. Let's go ahead and check our data folder now that we've done our analysis in ArcGIS Pro and see what we've got. We've got our original LAS file that we brought in from nationalmap.gov. We created a LAS data set from it, and then we have a geodatabase. Inside the geodatabase is all of our raster layers that we've created, as well as our vector layers. Keep on learning. Here are some resources to go further. Thanks.